tomorrow at lunchtime. So please join me in welcoming Dr. McDonald, who's speaking today about getting serious about STEM education reform, transforming learning through course-based undergraduate research experience.
All right, thank you. And James already told you what SIRIUS stands for. I usually make you guess for a couple of slides, but I'll tell you again in case you've forgotten that acronym already. And also, I think the SIRIUS project lends itself to lots of puns, but I think that my title might be my only pun today. I'm going to try anyway. But I'm really excited. I'm super excited to be here. I love Richmond. I had the opportunity to work with Virginia Union on some of this work a while back. This is only my second time to Richmond, but I really appreciate getting nearly blown off the pedestrian bridge last night with the raging James River underneath. That was spectacular.
Down 15 minutes.
I know, right? We went straight there. And no, I love Richmond. And I'm really excited. I've never been to VCU before, but I have been following James's work for a really long time with the River Science Field Network, right? And and it's super exciting. We're kind of in doing some parallel universe thing here, different ends of the country. But anyway, so thank you all very much for being here. So this worked a few minutes ago. Let me see if it just fell asleep. Okay, so the SIRIUS project is we are situated on the lands. We work on the waterways in Northern California. Sacramento State is right here in Sacramento, in the middle of California. These are all of our lovely rivers and tributaries and watershed. And so I always start with a land acknowledgement because of how closely the SIRIUS project is tied to our lands. And so I'm just going to read this because I think it's a pretty good land acknowledgement. So we acknowledge with respect the land our campus is on today was and continues to be the homelands of the indigenous people of this area, the Nisenan, and Miwok. The larger Sacramento area and its rivers serve as a gathering place for many local tribes still today from the surrounding valley and foothills, including the Southern Maidu, Patwin, and Winton. So we recognize these lands and riverways as unceded traditional territories of these native peoples. I further recognize these California Native nations and respect their sovereignty. By offering this land acknowledgement, we at Sac State affirm a commitment to build relationships and foster a university environment of success to better serve Native nations and communities. And I'll revisit how we've done this a little bit later on. So let me see if it works now. Oh, it does. Okay. So I also want to tell you a little bit about Sacramento State. I have a feeling we're like about a month. I was trying to figure out, I think we're about a month behind you all in terms of some really large reorganizations on campus. And so I've been joking that I might go home and be in a completely different college than when I left a couple of days ago. But as an institution, this is all pretty consistent right now. We're a large urban. We just turned R2 last week. And we're in the state's capital, like James said. We've got a similar number of students, I believe, to you all. We're about 31K. We're mostly undergrads. We do have some master's programs. I'm in biological sciences, has a master's, several master's programs. We have a couple of federal designations. We're a Hispanic serving institution and also an ANAPISI, so Asian American, Native American, Pacific Islander serving institution. We actually have a California designation as a Black serving institution, and we recently launched a Black Honors College, the first one in the United States, within the institution. And we're also partnering with a California tribal college and plan to, I'm a little fuzzy on this one, but I think we're also going to be integrating a tribal college into our institution very soon. So that's very exciting. We're about 30% first generation students, about close to 50% Pell eligible. And in terms of the biology department where today I reside, we've got about 1,400 majors and about 2,250 natural sciences and mathematics majors within our college. So our college has geography, geology, physics, math, biology, and chemistry. And so that's one of the reasons that that I've gotten to work so closely with so many people in different disciplines is because we're very close-knit college group, actually. So that's California State. And I want to give you a little bit of overview of what I'm planning to do today. I first want to talk about how we've really expanded access and opportunities for our students to do undergraduate research. And you'll see that I'm going to expand the definition of research soon because we've expanded the number of disciplines that we've been working with. And so to be more inclusive, we've kind of changed that research, but we'll talk about that later. And we've done this with integrating cures all over the place. I think we have now 40 or 50 classes in the Sirius 2 project now that have been redesigned. I'm going to talk a little bit about what led to the Sirius project, how my department started it, a little bit about Sirius 1, which was the early phase of this. And then Sirius 2 is the current phase of this. I've been working on this project for over 10 years now. We've been funded for 10 years. And then the second part of the talk, I want to talk about some best practices in cures. And all of the examples I'm going to give you are examples from our faculty. So not things that I've, a lot of this is in the literature as well, but some real examples from our faculty in Series 1 and Series 2. We've been adding a lot of community engagement to some of the cures. Enhancing research cultural capital. And so our students' awareness and understanding about what undergraduate research is, the norms around it, how to get it, and also just more student-centered and inclusive curriculum designs. So again, CURES, I think most of you, are familiar with that acronym, but course-based undergraduate research experiences. And again, the SIRIUS project, which I will never say this word again, this whole thing again, probably, sustainable interdisciplinary research to inspire undergraduate success. Okay, that's it. So this all began back in like 2011, 2012, something like that. And our inspiration for the first SIRIUS project really came from a combination of vision and change, where thought leaders and scientists from all over the country and lots of organizations and associations and funding agencies were calling for us to teach biology as it is performed by scientists, integrate more research into our curriculum. Then there was, and even before that, AAC&U would publish these high impact practices, and undergraduate research is right there. And then the PCAST report came out in 2012. And again, one of the 5 recommendations that the PCAST, for the President's Council of Advisors for Science and Technology, I believe, came out with was to redesign courses away from prescribed laboratories into more authentic research experiences. And so what our biology faculty did is we started having some informal journal clubs around vision and change. And you probably won't be surprised to learn that we could agree on almost nothing that they recommended, except that undergraduate research might be a good idea. And at our institution, we have UC Davis just about 30 minutes down the road. And so there's this kind of knowledge that UC Davis, that their students, let's just say they have a little more access to graduate programs, to medical schools, to stuff like that because of UC Davis and their name and their reputation. And so it was very important for us that we prepare our students in a way that they're going to be competitive. And one of the ways to be competitive to get into a PhD program or even a master's program is to have undergraduate research experience. So universally, that is the one recommendation that our faculty could agree on. And so we went with it from there. And the one thing I was going to say is if you have any questions about any of this along the way, just raise your hand. I like to kind of interact with the questions as we have them, because I'm going to kind of go through a lot of topics pretty quickly. We can revisit them later on if you're going to be at some of the other events. So anyway, the other thing is, as my biology my biology faculty are very data driven. And so one of the things that they were curious about when we start talking about this was 2 things. They said, well, 50% of our classes have hands-on laboratory experiences, which is pretty good, especially compared to UC Davis. They don't have very many of those at all. So that we win there. And so our faculty were like, well, maybe we're just giving them amazing experiences in these courses. So one of my grad students took the curriculum, and we used some rubrics that have been published, and we determined that even our capstone courses were very low levels of inquiry. So we came back and we said, nope, we're not giving our students very authentic experiences here as defined by, the literature. So then we said, well, but how many of our students are getting undergraduate research experiences? I mean, a lot of us do research. And so we said, well, we'll find out. And so we did a survey. We surveyed about 295 students who were mostly juniors and seniors. And we found that 91% of them actually expressed some sort of interest in doing undergraduate research. 12% reported some form of participation. But when we looked at what they described was their research experience. A lot of them were kind of conflating that with, I looked up a bunch of things online and did some research for my class that it wasn't research, or internships. They didn't know that, well, I'm interning at this hospital. And so really this is an overinflation of how many of our students were doing research. Barriers to participation, not surprising, lack of time. A lot of our students, almost all of our students work. They have to work. And they have families and they commute. We're mostly commuter campus. Lack of opportunity. And so again, our students were saying, I haven't had the opportunity to do a research experience. Some of them had been turned down from faculty who couldn't take them on. Lack of awareness. Only 12% said lack of awareness, but that kind of stuck with us because again, a lot of them didn't know what it was. But only 2% had a lack of interest. And so we also surveyed our faculty. We found out that 72%, now at the time, we were about half the size as we are now. And also we are an R2, so we've definitely grown in our research capability since then. But about 72% were mentoring undergraduates, but only about 2.5 students per year because at the time we were also a mostly teaching institution. Barriers were the same though, lack of time, lack of funding, and lack of space, right? So we concluded by doing some extrapolation that about less than 3% of our students in the department each year were getting undergraduate research experiences with our faculty, okay? So we took this back to the department and said, this is a problem. When we dug down a little deeper, unfortunately, the demographics of those who, again, this now wasn't those 295. We looked at everybody who had done undergraduate research experience at least for course credit or with the summer program I think we did like 4 years worth or something. Disproportionately white male, higher income, native freshmen, and with a parent who attended college, so not first generation, and they had to have high GPA. So these were our students who were getting those experiences. And transfer students, they got to participate less in UREs regardless of their GRE. And we have a large number of transfer students at our institution. So this was a bit depressing. The good news though is our faculty were motivated to mentor. Bad news was 70% were recruiting students from their classes, especially in upper division classes. So selection bias and et cetera going on, right? Okay, so that's a little bit of the history. I got a question for you because I am a STEM education researcher, and at the conferences I go to, you have to have a participatory sort of thing, or you get kicked out of the association or something like that. I'm not sure, but I am also very interested because I always like to know my audience, right? So, what barriers at UCA at VCU are experienced by your students who are seeking research experiences, and so what barriers might they have prior to all Rams a researcher, right? All research for Rams, all research for Rams. Every Rams a researcher. Okay, so prior to that, what are some of the barriers? Why might students not getting engaged in undergraduate research?
Shortage of mentors.
Shortage of mentors, yes.
Time, the same thing.
Time, same ones we have up there.
They don't know how to reach out.
Yes, research cultural capital. Yeah, anything else?
Time goes along with money, right? Like
Money.
especially if it's over the summer, like they might have to work.
Yeah, and the other thing about the money, this is a different project that I'm part of, but we're looking at barriers that students actually have while in a paid research experience. The number one, money.
Mm-hmm.
So they're being paid what we felt like is a good salary. It's through the Lewis Stokes for Alliance for Minority Participation. And they still report money being their number one barrier, even while they're in. So yeah. Anything else y'all can think of? You got some big ones.
Yeah, I think there's a lack of a pathway to like a clear end result. Like yes, you pursue the research and then you go get a master's degree, but like then what happens to you?
Yeah, exactly. Yeah, so are the research, it sounds like they might be competitive because you don't have enough faculty maybe, and so they might be a little bit competitive. You at least have to know how to get them, right? And then, how do your students learn about the opportunities? Do you have any training for them, or do you have any research centers on campus, or do you talk about it in your classes?
I'd say it's usually the motivated ones that reach out to us that know how to, or maybe like I have a project I need to get done and I'm like, this is a really sharp student in my class.
Yeah. So you can see how these things would bias the selection of of the students who get to do undergraduate research. And so this is just a published list of all of the barriers that, not all, some of the barriers. But again, the other thing is that the majority of students tend to get these faculty mentored or apprentice style research positions in their later years. But we know that the majority of students leave STEM right here. And so if these authentic, and a lot of them leave because they just don't see themselves being part of the scientific enterprise. A lot of them leave because they don't like how it's taught, very lecture focused, and they don't get enough hands-on. A lot of them leave because they don't see it benefiting their communities, society as a whole. So I'll come back to some of these things, but these are some of the others, and we mentioned a lot of them. Confidence to interact with faculty. I used to think, I have got to be the most approachable faculty member in our department, and still I have found out that like so many students are scared and terrified of me, right? So yeah, here's a big long list. So our question was, how can we provide all of our biology majors? We weren't trying to go campus wide like you all. That's ambitious. We just wanted to get all of our biology majors. So we decided to move towards the CURE model. So just as a quick refresher here, cures have been defined in the literature as having these tenets or criteria. So scientific practices, novel discovery with broad relevance outside the classroom, collaboration, iteration, and dissemination has been added there as well. The other thing that we decided to do, since we got a good group of faculty members engaged in this, was to try to scaffold. And we're a department of biological sciences. So we have our ecologists and our toxicologists and our cell molecular biologists and our anatomy physiologists all in one department, right? And so we came up with this shared goal or this shared theme of the health of or human impacts on the American River and its ecosystem. The American River runs through our campus. So it's a living laboratory for us. And so this is one of the little pats out to the American River here, faculty member taking some students. And we integrated these cures into both our laboratories and into our field experiences, our field labs. So again, this SIRIUS project, the first one was from 2014 to 2020. So just a little bit of an overview. Our goal for this grant really was to broaden this participation, right? Wanted everybody to have an opportunity. We also wanted them to have an opportunity to do multiple research experiences around a common theme, but to see different perspectives. So what does it look like to study this problem from a microbiologist perspective? What does it look like to study this problem from a ecologist perspective, and so forth? But to have a connection. And so our faculty really worked hard at kind of their messaging, depending on where the student was in the process. And then also we wanted to study a relevant local problem because we really wanted to contribute to the science of all of this and to our own communities. We had a faculty learning community. We started out with 19 biological sciences faculty, and through Keck Foundation funding, we were able to extend this to chemistry, environmental studies, and geology. So this was kind of SIRIUS 1, the first group. The SIRIUS 1 resulted in about 16 cures, or what I call cure modules, because some of our classes were connected. Like one of our introductory level courses got to a certain point, and students were immediately funneled into a genetics course that kind of picked it up from there because there wasn't enough time to do the whole thing. So we have some are connected in that way, but most of them were independent. And this was in 2019. We'd already engaged over 5,000 students, and now we've stopped counting. So this is kind of what our curriculum, there's only 8 of these, and the reason there's only 8 here is because first of all, I've only got the biology courses listed. There were 2 chemistry, 1 lower division and 1 upper division, 2 geology and 2 environmental studies courses as well. And then the biology cures that I don't have listed here were kind of these connector cures because we didn't study those to a large degree. With 3 scientific themes, so toxicology, ecology, molecular, micro. And so our Bio 1, fertilizer effects on river macroinvertebrates, this one kind of actually gave students some foundational knowledge in both of these themes. And then they went off to do some molecular and microbiology in Bio 2. You can see these are what we divided as intro, intermediate, and advanced courses. And then they pick these 2. So they have an intro here, an intermediate here, and then they've got 2 advanced courses, this one being micro and this one being molecular. And And then they start here with a toxicology / ecology. They have another ecology experience. This is kind of an intermediate it's definitely in the intermediate just because of where students take it and also the number of prerequisites it has. Yeah.
So with these projects that are embedded within each of these courses now, is it like the equivalent of a lab? So like it's like a couple of weeks, or is it like the entire lab of the class is taken over by the same?
Yes. So it's both.
Okay.
And so for instance, Bio 1, theirs was kind of spread throughout the semester because the Bio 1 was a pretty large class. And so they would go down and they'd learn some sampling at the river, but then huge tanks were collected and brought to the labs. And then they would kind of study the types of fertilizers that they knew to be in the American River from other people having pulled those data. And then they had a couple of choices because again, you have to be careful with your intro classes, right? That you kind of standardize them to some degree. And so then they would collect data, they learn some stuff, collect data early on, then they'd let them sit for a couple of weeks while they're doing other things, and then they'd come back and do another analysis and so forth. So this one I would say, maybe took up only 3 or 4 of the class periods. This one actually was two different parts that took up about 2/3 of this class. Some of these are the entire semester. Yeah, just gutted. One of these, interestingly, 127 started out as like 3 weeks. And I looked at it and I was like, yeah, that's, it's a lot. And it ended up being 8 weeks because the students loved it. The faculty member loved it more than the rest of it. And so some of them started small and then started to grow. But yeah, so this is kind of how they were scaffolded across the curriculum. And then just to really quickly to say, 2 of our goals were we wanted to develop these cures, and then we wanted to see our faculty actually doing cures. So one of my students did some course analysis using syllabi and lab manuals and presentations and all the above, and discovered that where the X's are is where they meet all of the criteria for a cure. And then we had to go back and actually talk to some of the faculty to find out a little bit more about some of the things they do. And so at the end of the day, we were pretty excited that they met the definitions of these cures, right? Yeah.
What's the enrollment in these classes?
Yeah, so our Bio 1 and our Bio 2 sections have 24 students each. And those are the largest labs, but then Bio 1 will run like 20 sections of 24. Bio 2 has more like 8 sections of 24. As we get on up here, some of these are limited to 16 students, and none of these have more than 1 or 2 sections of lab at the most. In fact, I think all of these have 1 section, so that's another criteria for the advanced.
Building on that question, the lecture components of those classes, are they very much embedded with the labs, or are they're completely independent?
The way the schedule looks is that the majority of them have very distinct lecture and labs. However, for instance, some of these, like Bio 180, which is our advanced molecular biology class, that faculty member, because he really wanted to grow the kind of intensity of his curriculum, he was able to go in and change the design to have 2 longer periods where now they're integrated. So again, these up here, because they're high enrollment, lots of sections, they're pretty standard. Here's your lecture, here's your lab, they are independent and all of that. Some of the advanced ones, though, have changed the way they operate. That's a great question. Some of these here, so our TAs are all master students. We don't have any PhD students, and they are all in our lower division only courses. But the first year we did, we forgot about that early on. We also forgot that a lot of these faculty, and even some here, are non-tenure track faculty, and that we have more rotation. We have some long-term lecturers, which is great because we did have them involved in planning all of these, designing the curriculum, meeting in the faculty, learning community. But we failed to think about, well, how are we going to train all of the 20 sections of people who are teaching Bio 1? So we had to go back and actually develop some training and I used to run the GTA program, our graduate teaching associate program. So I had sections on cures, how to teach a cure. Yeah. So that's a great question. It's a challenge.
Yeah, I'm wondering what the iteration component looks like, because for me, that's the hardest probably in practice to implement.
Yeah.
So we in my forest ecology course, we do this spin up this big project and then they present it and then it's done, right? And just so building in the time for that, I think especially at the end, before communications.
Yeah. Iteration has been taken probably a little too narrowly. Like, so those of us who've been in the cure research and doing a lot of cures for so many years and talking about it, iteration can look like a lot of things. So iteration can simply be that the Bio 1 students, they look at the data from the Bio 1 students the semester before, and that gets them kind of oriented to the project and to the data and to the hypotheses that the students were generating. And then they kind of decide whether they're going to generate new hypotheses. If, you know, they kind of work it out as to whether they're going to retest something because it's a different semester. And last we had a drought and now we have flooding, you know. So iteration can simply look at continuing, or can be, you know, continuing a project, looking at data before that came to you. Iteration can also mean in the way you do assessments. If somebody's putting in like in some of our advanced classes, they learn some of the techniques early on. And so they may learn like, you know, flow cytometry or something like that, not with their samples. They write a proposal of what they want to test in that class. They get, the faculty member gets the proposal and, you know, marks it all up and says, you need to redo this because of whatever. Okay, now they're rethinking some of this process. I mean, so it can even be an assessment, you know, with feedback, you know, is part of the iterative process. So iteration doesn't mean you have to repeat the entire thing, because only Bio 2 does that actually, where they have got it set up where they're running these two things in parallel, a micro and a molecular, and they actually have time to redo their DNA extraction and their PCR. So a lot of them don't. Iteration can also look like in 130, here they're learning some aseptic techniques and some micro stuff and using real samples. And here they're actually doing some more advanced, kind of taking what they learned from Bio 2, doing a little bit of sort of review and then taking off from there. So yeah, they'll keep it, yeah, it's impossible. Yeah.
I know this is more like a detailed question, but you said in the Bio 1 course, they travel into the field at some point to see them before they do it. How do you deal with transportation for the term?
Oh, they walk out the door and down to the river. It is literally the building that they're in. The river is right next to it. So so a couple of our classes, not all of them actually go out to the river though, but I think three or four, they go all over the place, but they're ecology class. So yeah. Does that answer those questions for now? Okay, good. Those are great questions. Just to show you real quick, I'm not gonna breeze over this really quickly, but these are some violin plots where one of the things that we did was we used the laboratory course assessment survey, and it has students report back on how much collaboration did you engage in? How much discovery and relevance, you know, just novel discovery were you doing? How much iteration were you doing? These types of things. But it does that in terms of breaking it down into very specific questions. Do you have a question about LCAS?
Is it like within the members of the same course?
Yes. Yeah. So the teamwork within the course is what these questions are geared towards. Yeah. And so what we were trying to look at here is this whole idea of scaffolding. And so are we seeing like, and what we were seeing, so these are medians, and what we were seeing is significant differences in our advanced courses. So we pooled these data. So our advanced courses were really looking different from our intermediate, and even though there's a statistical difference here between intro and intermediate. For collaboration, discovery, again, students were seeing more discovery in the advanced classes, and iteration as well, which, you know, they were recognizing. And so I don't have time to get down into the actual questions, but those are kind of more, they're really more distinct about what students were doing in those classrooms. It's a 17 item tool. But this gave us some really good way, like, okay, we think that these advanced students are recognizing these activities. This was a really fun part of it too. We just literally asked them, do you feel like you're doing real science in your lab, and why? The why or why nots were great. But as you can see, introductory students, about 85% were saying yes. These are our sample sizes right here. 85% were saying yes, but then you'd ask them why, and they're like, oh, because, you know, we used We did what I saw them do on CSI, we use the same instruments or, something like that, especially before the cures. After the cures, we saw those rationales really change. But up here, 98% of the advanced, they were just nailing the definitions, like the discovery, the relevance, all of those things. And we weren't sharing that with them in advance. So we have a lot of data. One of my grad students has published all of her data on this. But yeah, we think it matters to ask students about their perceptions of what they're doing because of this thing right here, this sense of ownership that students really get with these cures. And as one example, these predict basically whether they want to stay in STEM, whether they want to go to grad school, those types of things. So, all right, so SIRIUS 2 in a couple of minutes. So we expanded to 10 disciplines. We partnered with 5 community colleges, multi-year community of practice. We're calling them CALES now, course-based authentic learning experiences, and I'll show you why in a minute. Really focusing on interdisciplinary, community-based curriculum, and just expanded the region in which we are operating. And this is a 5-year grant. We're at the end of this one right here. And so the reason we expanded our definition to CALES is because we still want them to be solving real world problems. But we said, our engineers, they were like, well, what does research look like in engineering? What does research look like in math? And even some physicists and stuff like that, geography, right? So these CALES are still cures if it's really a research-based project, right? Or it could be a project or problem-based. They're building instrumentation, right? It can be design or client-based. We've got GIS classes that pretend that a certain class is a client and they build management systems around, the data and stuff like that. And so these are just some examples. Again, a micro lab where they're testing for bacterial metabolites, biodiversity, waterways, sampling, monitoring, hypothesis-based studies, mapping, more modeling and designing. That's what these look like. And just really quickly, these are the disciplines that we've currently got in the program. About 43 faculty, divided up about half and half from community colleges and from Sac State. So I want to show you some examples of these. So this is at the community college, and this is a micro class, and this is a micro class for primarily healthcare majors. And so this faculty member, a lot of pre-nursing. So this faculty member was like, I've got to get my pre-nursing students interested in, what looks like a very ecology-based class here, or cure theme. And so basically they're identifying, isolating, and quantifying coliform bacteria in the water samples. And so they work that into a lesson on coliforms and E. coli flares and, all of that stuff. And we've got a lot of that in different areas of the community in an urban area like this that also you have animals, we have large encampments for unhoused individuals, and there have been some articles in our local newspaper that have suggested that the encampments have been this problem, but that's been very controversial and we don't know that is. And so anyway, she wraps that into this. There's a collaboration at one of our community colleges between chemists and biologists, and they are developing microfluid-based methods to detect various chemicals in different water samples. And then we've got this one now. This isn't a hypothesis-driven. Basically what they're doing here is a project where they are organizing herpetology collections. They're developing a database that's being shared both at Sac State and beyond in the community. So this is something where it's more of a community-based project, but it's actually less reciprocal. And I'm going to show you some examples of some reciprocal community-based projects. Our engineers and geologists are working together. There's a project involving erosion and levees, a levee improvement project. And so they're working together and collecting data and sharing it across these different, even different colleges. We're not even in the same college, right? So that's pretty cool. And then I love this one. Okay, so we have an advanced electronics and instrumentation course in physics, and they are building instrumentation, this is them over here, building instrumentation for students in the introductory level physics course to test using water samples when they're studying flow and turbidity. And then the intro students get to give feedback back to at least the faculty member, if not the students, if they're not still around. Geology and engineering are also collaborating in this. And so we found that this is just a few things that they've said, they're super excited about, right, really owning the project. They also get super stressed out though, because they're like, we've got to get these to, it's like they have a timeline, right? And they have a deadline, and we've got to get these to the undergraduates by this time. And they're really concerned about whether they work, because what if these intro students, have a failed piece of equipment? And so, and so it's really fun. They also can't believe that their professor doesn't always have the answers. And so that happens all the time when they're building new equipment. So this has been published. It's so great. This has been published in American Journal of Physics. And so by the two faculty members who are doing that. All right, so I'm going to finish up in just a couple minutes on these like kind of best practices in KLs. What we really wanted to do is maximize the benefits, minimize barriers for a really diverse population of students that we have. So part of the way we've done this is by designing community-based KLs and cures, enhancing research cultural capital, and using student-centered inclusive practices. And so if you have any questions about these, let me know. But with our community engagement, the equity ethic by McGee and Bentley really talks about how some students have left the fields of engineering. Actually, McGee is an engineer, and she's a Black woman, was a professor, left engineering, and she's done a lot of studying about how students, especially from minoritized populations, may leave because they don't feel like their project is going to help the good of their communities, or that science isn't, that it's very detached from societal issues. So anyway, when you bring in some community engagement project, then it kind of relieves some of that. It also makes the relevance part of cures much more obvious. When you are getting the community voices, not only are you really getting problems that need to be solved and going back and forth, but we also know this is an ethical practice. And then place-based learning also, if you're able to do this in your own area, especially where students are familiar with, they live, they may fish, they may boat, they may swim, all of those things, then that's pretty engaging for them. So we have a restoration ecology lab. Bushy Lake is in Sacramento, and this professor has collaborated with lots of different community partners and to help with funding and support, but also with indigenous leaders to bring in some curriculum about culturally significant plants. We have this one. This is a field geography course where this professor, we have an area called the River District, which is right down on the river. And she had two different projects where one was to identify formal and informal access areas to the American River in this multi-use district that was really being kind of revitalized, and then making recommendations on ways to improve access, safety, all of that. And this is her class. I went on that field trip with them, and it was really fun. And another one was really just looking at other big cities on rivers and seeing how do they identify as a river city, and making some recommendations about, this idea of place, right? And this student, I appreciated how much real world experience and contact I got with real life planners, because they were working with urban planners to do this. And some of these students want to be in urban planning. So that was very cool. And I'm just going to say really quickly about the research cultural capital. This is a whole master's project, but Eric Panino developed a 2-part professional development workshop that you can do in 30 minutes in 2 sessions in introductory biology courses to actually engage students in talking about what undergraduate research is, why might you want to do it, why might you not want to do it, bringing in students who are performing undergraduate research. And he published his curriculum in Course Source, and then we're working on publishing the assessment of the efficacy. But a lot of this is about making students aware of what it is, and how we actually even write emails to faculty, or they analyze a very poorly written email to a faculty member and in the class. And these are usually freshman students. And then very lastly, I would say that a couple of the things that our faculty have done is helping students feel safe doing field work. So this may pertain to some of you, one of the things they do is they survey students about their feelings of safety before they go out into the environment where they're going. And so kind of these anonymous reflections that students will write about, you know, what they anticipate.
The wilderness.
Yeah, out in wilderness. Yeah, some of our students, this is an urban campus, and some of them have never been out into the wilderness. And then also, they've established relationships with park rangers or other like law enforcement that might be in these areas to make sure that this won't be triggering for some of their students. And then they, of course, discuss the precautions, introduce them to the site by videos or, you know, other types of things. Just turn that off. Okay.
Okay, there we go.
Yeah. So that's been, I've read some of those reflections and they're really, really nice, really nicely done. Increasing representation and cultural knowledge. And so if y'all haven't heard of scientist spotlights, this is a great, you can just Google scientist spotlights. It's a great project where the curriculum's already been done for you. And it's about scientists across a very broad spectrum of the life sciences from minoritized communities. They and their students have actually created the curriculum, and you can present these people to your classroom and give examples of what they're doing in their research, if it aligns with what you're doing in your research. So a lot of our faculty use scientist spotlights, acknowledge the unceded tribal territories, and again, even work with cultural experts, ethnobiologists or tribal descendants when they're out in the field doing some of this work. And then they also challenge students to think about who might be benefiting from what they're doing and who may be left out of or not benefiting from that. And then this is my last slide. So some curricular and pedagogical practices that other faculty are using. So this idea of iteration, you really want to think about how you're assessing when you're doing cures, because it's not the same as a prescribed laboratory. And so sometimes, you know, this kind of feedback, a lot of our faculty use mastery grading or specification grading. They don't even use a 0 to 100 scale anymore, which is really nice. Supporting, there's ways to support teamwork. Science of team science framework is really good for that. If anybody's interested, I can talk with you at length about that. And then, you know, scaffolding activities with very well-defined roles and clear expectations, using teaching assistants, if you have them, even undergrad assistants who've taken your classes before, to increase, you know, access to feedback. We love to have students have to write an elevator pitch on their research as an assessment tool, because they can use that in applying for jobs. In, you know, we want to make sure this stuff goes on their resumes. We integrate other professional skills like entrepreneurial mindset and normalizing failure. The more you can do that, you know, how are all the ways you've failed in research, right? And that always helps students a lot with this. And what I want to do is, you've heard all of this before, but I'm going to skip over the very last part where I was going to talk about the research question, and I've got some very cool social network analysis, but I didn't think I'd get to that. It's okay. I want to answer questions. This is our group, and these are the SIRIUS PIs. Tom Landerholm started all of this with me, and unfortunately passed away very young a couple of years ago. These are the current PIs, and Linda is a community college faculty. We've had a lot of student researchers, and a lot of these have gotten their master's theses actually studying the SIRIUS project. And then this is Team Beer, biologists engaged in education research. These are not all my students. There's a couple other faculty, but we all work together on all of this. And yeah, and I want to be respectful of time and see if you have any questions. So.